This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recorded by Julian Jameson. The Origin of Species by Means of Natural Selection, or the Preservation of Favored Races in the Struggle for Life. 6th London edition, by Charles Darwin. Chapter number 10. On the Imperfection of the Geological Record. Part A. Contents of this chapter include: on the absence of intermediate varieties at the present day, on the nature of extinct intermediate varieties, on their number, on the lapse of time as inferred from the rate of denudation and of deposition number, on the lapse of time as estimated by years, on the poorness of our paleontological collections, on the intermittence of geological formations, on the denudation of granitic areas, on the absence of intermediate varieties in any one formation, on the sudden appearance of groups of species, on their sudden appearance in the lowest known fossiliferous strata, antiquity of the habitable earth. In the 6th chapter, I enumerated the chief objections which might be justly urged against the views maintained in this volume. Most of them have now been discussed. One, namely, the distinctness of specific forms and their not being blended together by innumerable transitional links, is a very obvious difficulty. I assigned reasons why such links do not commonly occur at the present day under the circumstances apparently most favorable for their presence, namely, on an extensive and continuous area with graduated physical conditions. I endeavored to show that the life of each species depends in a more important manner on the presence of other already defined organic forms than on climate, and therefore that the really governing conditions of life do not graduate away quite insensibly like heat or moisture. I endeavored also to show that intermediate varieties, from existing in lesser numbers than the forms which they connect, will generally be beaten out and exterminated during the course of further modification and improvement. The main cause, however, of innumerable intermediate links not now occurring everywhere throughout nature depends on the very process of natural selection, through which new varieties continually take the places of and supplant their parent forms. But just in proportion as this process of extermination has acted on an enormous scale, so must the number of intermediate varieties which have formerly existed be truly enormous. Why, then, is not every geological formation and every stratum full of such intermediate links? Geology assuredly does not reveal any such finely graduated organic chain, and this perhaps is the most obvious and serious objection which can be urged against my theory. The explanation lies, as I believe, in the extreme imperfection of the geological record. In the first place, it should always be borne in mind what sort of intermediate forms must, on the theory, have formerly existed. I have found it difficult, when looking at any two species, to avoid picturing to myself forms directly intermediate between them. But this is a wholly false view. We should always look for forms intermediate between each species and a common but unknown progenitor, and the progenitor will generally have differed in some respects from all its modified descendants. To give a simple illustration, the fantail and pouter pigeons are both descended from the rock pigeon. If we possessed all the intermediate varieties which have ever existed, we should have an extremely close series between both and the rock pigeon, but we should have no varieties directly intermediate between the fantail and pouter. None, for instance, combining a tail somewhat expanded with a crop somewhat enlarged, the characteristic features of these two breeds. These two breeds, moreover, have become so much modified that if we had no historical or indirect evidence regarding their origin, it would not have been possible to have determined from a mere comparison of their structure with that of the rock pigeon, C. lavia, whether they had descended from this species or from some other allied species, such as C. oenas. So with natural species, if we look to forms very distinct, for instance to the horse and tapir, we have no reason to suppose that links directly intermediate between them ever existed, but between each and an unknown common parent. The common parent will have had in its whole organization much general resemblance to the tapir and to the horse, but in some points of structure may have differed considerably from both, even perhaps more than they differ from each other. Hence, in all such cases, we should be unable to recognize the parent form of any two or more species, even if we closely compared the structure of the parent with that of its modified descendants, unless at the same time we had a nearly perfect chain of the intermediate links. It is just possible, by the theory, that one of two living forms might have descended from the other, for instance, a horse from a tapir, and in this case direct intermediate links will have existed between them. But such a case would imply that one form had remained for a very long period unaltered, whilst its descendants had undergone a vast amount of change, and the principle of competition between organism and organism, between child and parent, will render this a very rare event. For in all cases the new and improved forms of life tend to supplant the old and unimproved forms. By the theory of natural selection, all living species have been connected with the parent species of each genus, by differences not greater than we see between the natural and domestic varieties of the same species at the present day, and these parent species, now generally extinct, have in their turn been similarly connected with more ancient forms, and so on backwards, always converging to the common ancestor of each great class, so that the number of intermediate and transitional links between all living and extinct species must have been inconceivably great. But assuredly, if this theory be true, such have lived upon the earth. On the lapse of time as inferred from the rate of deposition and extent of denudation. Independently of our not finding fossil remains of such infinitely numerous connecting links, it may be objected that time cannot have sufficed for so great an amount of organic change, all changes having been effected slowly. It is hardly possible for me to recall to the reader, who is not a practical geologist, the facts leading the mind feebly to comprehend the lapse of time. He who can read Sir Charles Lyell's grand work on the principles of geology, which the future historian will recognize as having produced a revolution in natural science, and yet does not admit how vast have been the past periods of time, may at once close this volume. Not that it suffices to study the principles of geology, or to read special treatises by different observers on separate formations, and to mark how each author attempts to give an inadequate idea of the duration of each formation, or even of each stratum. We can best gain some idea of past time by knowing the agencies at work, and learning how deeply the surface of the land has been denuded, and how much sediment has been deposited. As Lyell has well remarked, the extent and thickness of our sedimentary formations are the result and the measure of the denudation which the earth's crust has elsewhere undergone. Therefore a man should examine for himself the great piles of superimposed strata, and watch the rivulets bringing down mud, and the waves wearing away the sea cliffs, in order to comprehend something about the duration of past time, the monuments of which we see all around us. It is good to wander along the coast, when formed of moderately hard rocks, and mark the process of degradation. The tides, in most cases, reach the cliffs only for a short time, twice a day, and the waves eat into them only when they are charged with sand or pebbles, for there is good evidence that pure water effects nothing in wearing away rock. At last, the base of the cliff is undermined, huge fragments fall down, and these, remaining fixed, have to be worn away atom by atom, until after being reduced in size they can be rolled about by the waves, and then they are more quickly ground into pebbles, sand, or mud. But how often do we see along the bases of retreating cliffs rounded boulders, all thickly clothed by marine productions, showing how little they are abraded, and how seldom they are rolled about? Moreover, if we follow for a few miles any line of rocky cliff which is undergoing degradation, we find that it is only here and there, along a short length or round a promontory, that the cliffs are at the present time suffering. The appearance of the surface and the vegetation show that elsewhere years have elapsed since the waters washed their base. We have, however, recently learned from the observations of Ramsay, in the van of many excellent observers, of Jukes, Geikie, Kroll, and others, that subaerial degradation is a much more important agency than coast action, or the power of the waves. The whole surface of the land is exposed to the chemical action of the air and of the rainwater, with its dissolved carbonic acid, and in colder countries to frost. The disintegrated matter is carried down even gentle slopes during heavy rain, and to a greater extent than might be supposed, especially in arid districts, by the wind. It is then transported by the streams and rivers, which, when rapid, deepen their channels, and triturate the fragments. On a rainy day, even in a gently undulating country, we see the effects of subaerial degradation in the muddy rills which flow down every slope. Messrs. Ramsay and Whitaker have shown, and the observation is a most striking one, that the great lines of escarpment in the Wealdian district, and those ranging across England, which formerly were looked at as ancient sea-coasts, cannot have been thus formed, for each line is composed of one and the same formation, while our sea-cliffs are everywhere formed by the intersection of various formations. This being the case, we are compelled to admit that the escarpments owe their origin in chief part to the rocks of which they are composed, having resisted subaerial denudation better than the surrounding surface. This surface consequently has been gradually lowered, with the lines of harder rock left projecting. Nothing impresses the mind with the vast duration of time, according to our ideas of time, more forcibly than the conviction thus gained that subaerial agencies, which apparently have so little power, and which seem to work so slowly, have produced great results. When thus impressed with the slow rate at which the land is worn away through subaerial and littoral action, it is good, in order to appreciate the past duration of time, to consider on the one hand the masses of rock which have been removed over many extensive areas, and on the other hand the thickness of our sedimentary formations. I remember having been much struck when viewing volcanic islands, which have been worn by the waves and pared all round into perpendicular cliffs of 1,000 or 2,000 feet in height. For the gentle slope of the lava streams, due to their formerly liquid state, showed at a glance how far the hard, rocky beds had once extended into the open ocean. The same story is told still more plainly by faults, those great cracks along which the strata have been upheaved on one side, or thrown down on the other, to the height or depth of thousands of feet. For since the crust cracked, and it makes no great difference whether the upheaval was sudden, or, as most geologists now believe, was slow and effected by many starts, the surface of the land has been so completely planed down that no trace of these vast dislocations is externally visible. The Craven Fault, for instance, extends for upward of 30 miles, and along this line the vertical displacement of the strata varies from 600 to 3,000 feet. Professor Ramsay has published an account of a downthrow in Anglesey of 2,300 feet, and he informs me that he fully believes that there is one in Merionethshire of 12,000 feet. Yet in these cases there is nothing on the surface of the land to show such prodigious movements, the pile of rocks on either side of the crack having been smoothly swept away. On the other hand, in all parts of the world the piles of sedimentary strata are of wonderful thickness. In the Cordillera I estimated one mass of conglomerate at 10,000 feet, and although conglomerates have probably been accumulated at a quicker rate than finer sediments, yet from being formed of worn and rounded pebbles, each of which bears the stamp of time, they are good to show how slowly the mass must have been heaped together. Professor Ramsay has given me the maximum thickness, from actual measurement in most cases, of the successive formations in different parts of Great Britain, and this is the result. Paleozoic strata, not including igneous beds, 57,154 feet. Secondary strata, 13,190 feet. Tertiary strata, 2,240 feet, making altogether 72,584 feet, that is, very nearly 13 3/4 British miles. Some of these formations, which are represented in England by thin beds, are thousands of feet in thickness on the continent. Moreover, between each successive formation we have, in the opinion of most geologists, blank periods of enormous length, so that the lofty pile of sedimentary rocks in Britain gives but an inadequate idea of the time which has elapsed during their accumulation. The consideration of these various facts impresses the mind almost in the same manner as does the vain endeavour to grapple with the idea of eternity. Nevertheless, this impression is partly false. Mr. Croll, in an interesting paper, remarks that we do not err "in forming too great a conception of the length of geological periods, but in estimating them by years. When geologists look at large and complicated phenomena, and then at the figures representing several million years, the two produce a totally different effect on the mind, and the figures are at once pronounced too small. In regard to subaerial denudation, Mr. Croll shows, by calculating the known amount of sediment annually brought down by certain rivers, relatively to their areas of drainage, that 1,000 feet of solid rock, as it became gradually disintegrated, would thus be removed from the mean level of the whole area in the course of 6 million years. This seems an astonishing result, and some considerations lead to the suspicion that it may be too large, but if halved or quartered, it is still very surprising. Few of us, however, know what 1,000,000 really means. Mr. Croll gives the following illustrations. Take a narrow strip of paper, 83 feet 4 inches in length, and stretch it along the wall of a large hall. Then mark off at one end the 1/10 of an inch. This 1/10 of an inch will represent 100 years, and the entire strip 1,000,000 years. But let it be borne in mind, in relation to the subject of this work, what 100 years implies, represented as it is by a measure utterly insignificant in a hall of the above dimensions. Several eminent breeders, during a single lifetime, have so largely modified some of the higher animals, which propagate their kind much more slowly than most of the lower animals, that they have formed what well deserves to be called a new subbreed. Few men have attended with due care to any one strain for more than half a century, so that 100 years represents the work of 2 breeders in succession. It is not to be supposed that species in a state of nature ever change so quickly as domestic animals under the guidance of methodical selection. The comparison would be in every way fairer with the effects which follow from unconscious selection, that is, the preservation of the most useful or beautiful animals, with no intention of modifying the breed. But by this process of unconscious selection, various breeds have been sensibly changed in the course of 2 or 3 centuries. Species, however, probably change much more slowly, and within the same country only a few change at the same time. This slowness follows from all the inhabitants of the same country being already so well adapted to each other, that new places in the polity of nature do not occur until after long intervals, due to the occurrence of physical changes of some kind, or through the immigration of new forms. Moreover, variations or individual differences of the right nature, by which some of the inhabitants might be better fitted to their new places under the altered circumstance, would not always occur at once. Unfortunately, we have no means of determining, according to the standard of years, how long a period it takes to modify a species. But to the subject of time we must return. On the poorness of paleontological collections. Now let us return to our richest museums, and what a paltry display we behold. That our collections are imperfect is admitted by everyone. The remark of that admirable paleontologist, Edward Forbes, should never be forgotten, namely, that very many fossil species are known and named from single and often broken specimens, or from a few specimens collected on some one spot. Only a small portion of the surface of the earth has been geologically explored, and no part with sufficient care, as the important discoveries made every year in Europe prove. No organism wholly soft can be preserved. Shells and bones decay and disappear when left on the bottom of the sea, where sediment is not accumulating. We probably take a quite erroneous view when we assume that sediment is being deposited over nearly the whole bed of the sea at a rate sufficiently quick to embed and preserve fossil remains. Throughout an enormously large proportion of the ocean, the bright blue tint of the water bespeaks its purity. The many cases on record of a formation conformably covered, after an immense interval of time, by another and later formation, without the underlying bed having suffered in the interval any wear and tear, seem explicable only on the view of the bottom of the sea not rarely lying for ages in an unaltered condition. The remains which do become embedded, if in sand or gravel, will, when the beds are upraised, generally be dissolved by the percolation of rain-water charged with carbonic acid. Some of the many kinds of animals which live on the beach between high and low water mark seem to be rarely preserved. For instance, the several species of the Chthamalinea, a subfamily of sessile cirripedes, coat the rocks all over the world in infinite numbers. They are all strictly littoral, with the exception of a single Mediterranean species, which inhabits deep water, and this has been found fossil in Sicily, whereas not one other species has hitherto been found in any tertiary formation. Yet it is known that the genus Chthamalus existed during the Chalk period. Lastly, many great deposits requiring a vast length of time for their accumulation are entirely destitute of organic remains, without our being able to assign any reason. One of the most striking instances is that of the Flesch formation, which consists of shale and sandstone, several thousand, occasionally even 6,000 feet in thickness, and extending for at least 300 miles from Vienna to Switzerland, and although this great mass has been most carefully searched, no fossils, except a few vegetable remains, have been found. With respect to the terrestrial productions which lived during the secondary and Paleozoic periods, it is superfluous to state that our evidence is fragmentary in an extreme degree. For instance, until recently not a land shell was known belonging to either of these vast periods, with the exception of one species discovered by Sir C. Lyell and Dr. Dawson in the Carboniferous strata of North America. But now land shells have been found in the Lias. In regard to mammiferous remains, a glance at the historical table published in Lyell's manual, which bring home the truth, how accidental and rare is their preservation, far better than pages of detail. Nor is their rarity surprising, when we remember how large a proportion of the bones of tertiary mammals have been discovered either in caves or in lacustrine deposits, and that not a cave or true lacustrine bed is known belonging to the age of our secondary or Paleozoic formations. But the imperfection in the geological record largely results from another and more important cause than any of the foregoing, namely, from the several formations being separated from each other by wide intervals of time. This doctrine has been emphatically admitted by many geologists and paleontologists, who, like E. Forbes, entirely disbelieve in the change of species. When we see the formations tabulated in written works, or when we follow them in nature, it is difficult to avoid believing that they are closely consecutive. But we know, for instance, from Sir R. Murchison's great work on Russia, what wide gaps there are in that country between the superimposed formations. So it is in North America, and in many other parts of the world. The most skillful geologist, if his attention had been confined exclusively to these large territories, would never have suspected that during the periods which were blank and barren in his own country, great piles of sediment, charged with new and peculiar forms of life, had elsewhere been accumulated. And if in every separate territory hardly any idea can be formed of the length of time which has elapsed between the consecutive formations, we may infer that this could nowhere be ascertained. The fragment and great changes in the mineralogical composition of consecutive formations, generally implying great changes in the geography of the surrounding lands, whence the sediment was derived, accord with the belief of vast intervals of time having elapsed between each formation. We can, I think, see why the geological formations of each region are almost invariably intermittent, that is, have not followed each other in close sequence. Scarcely any fact struck me more when examining many hundred miles of the South American coasts, which have been upraised several hundred feet within the recent period, than the absence of any recent deposits sufficiently extensive to last for even a short geological period. Along the whole west coast, which is inhabited by a peculiar marine fauna, tertiary beds are so poorly developed that no record of several successive and peculiar marine faunas will probably be preserved to a distant age. A little reflection will explain why, along the rising coast of the western side of South America, no extensive formations with recent or tertiary remains can anywhere be found, though the supply of sediment must for ages have been great, from the enormous degradation of the coast rocks, and from the muddy streams entering the sea. The explanation, no doubt, is that the littoral and sublittoral deposits are continually worn away, as soon as they are brought up by the slow and gradual rising of the land within the grinding action of the coast waves. We may, I think, conclude that sediment must be accumulated in extremely thick, solid, or extensive masses, in order to withstand the incessant action of the waves, when first upraised and during subsequent oscillations of level, as well as the subsequent subaerial degradation. Such thick and extensive accumulations of sediment may be formed in two ways, either in profound depths of the sea, in which case the bottom will not be inhabited by so many and such varied forms of life as the more shallow seas, and the mass when upraised will give an imperfect record of the organisms which existed in the neighborhood during the period of its accumulation. Or sediment may be deposited to any thickness and extent over a shallow bottom if it continue slowly to subside. In this latter case, as long as the rate of subsidence and supply of sediment nearly balance each other, the sea will remain shallow and favourable for many and varied forms, and thus a rich fossiliferous formation, thick enough when upraised to resist a large amount of denudation, may be formed. I am convinced that nearly all our ancient formations, which are throughout the greater part of their thickness rich in fossils, have thus been formed during subsidence. Since publishing my views on this subject in 1845, I have watched the progress of geology, and have been surprised to note how author after author, in treating of this or that great formation, has come to the conclusion that it was accumulated during subsidence. I may add that the only ancient tertiary formation on the west coast of South America, which has been bulky enough to resist such degradation as it has as yet suffered, but which will hardly last to a distant geological age, was deposited during a downward oscillation of level, and thus gained considerable thickness. All geological facts tell us plainly that each area has undergone numerous slow oscillations of level, and apparently these oscillations have affected wide spaces. Consequently, formations rich in fossils and sufficiently thick and extensive to resist subsequent degradation will have been formed over wide spaces during periods of subsidence, but only where the supply of sediment was sufficient to keep the sea shallow and to embed and preserve the remains before they had time to decay. On the other hand, as long as the bed of the sea remained stationary, thick deposits cannot have been accumulated in the shallow parts, which are the most favourable to life. Still less can this have happened during the alternate periods of elevation, or, to speak more accurately, the beds which were then accumulated will generally have been destroyed by being upraised and brought within the limits of the coast action. These remarks apply chiefly to littoral and sublittoral deposits. In the case of an extensive and shallow sea, such as that within a large part of the Malay archipelago, where the depth varies from 30 or 40 to 60 fathoms, a widely extended formation might be formed during a period of elevation, and yet not suffer excessively from denudation during its slow upheaval. But the thickness of the formation could not be great, for owing to the elevatory movement, it would be less than the depth in which it was formed, nor would the deposit be much consolidated, nor be capped by overlying formations, so that it would run a good chance of being worn away by atmospheric degradation and by the action of the sea during subsequent oscillations of level. It has, however, been suggested by Mr. Hopkins that if one part of the area, after rising and before being denuded, subsided, the deposit formed during the rising movement, though not thick, might afterwards become protected by fresh accumulations, and thus be preserved for a long period. Mr. Hopkins also expresses his belief that sedimentary beds of considerable horizontal extent have rarely been completely destroyed. But all geologists, excepting the few who believe that our present metamorphic schists and plutonic rocks once formed the primordial nucleus of the globe, will admit that these latter rocks have been stripped of their covering to an enormous extent. For it is scarcely possible that such rocks could have been solidified and crystallized while uncovered, but if the metamorphic action occurred at profound depths of the ocean, the former protecting mantle of rock may not have been very thick. Admitting, then, that gneiss, mica schist, granite, diorite, etc., were once necessarily covered up, how can we account for the naked and extensive areas of such rocks in many parts of the world, except on the belief that they have subsequently been completely denuded of all overlying strata? That such extensive areas do exist cannot be doubted. The granitic region of Parimé is described by Humboldt as being at least 19 times as large as Switzerland. South of the Amazon, Boué colors an area composed of rocks of this nature as equal to that of Spain, France, Italy, part of Germany, and the British Isles, all conjoined. This region has not been carefully explored, but from the concurrent testimony of travellers, the granitic area is very large. Thus von Eschwege gives a detailed section of these rocks, stretching from Rio de Janeiro for 260 geographical miles inland in a straight line. And I travelled for 150 miles in another direction, and saw nothing but granitic rocks. Numerous specimens, collected along the whole coast from near Rio de Janeiro to the mouth of the Plata, a distance of 1,100 geographical miles, were examined by me, and they all belonged to this class. Inland, along the whole northern bank of the Plata, I saw, besides modern tertiary beds, only one small batch of slightly metamorphosed rock, which alone could have formed a part of the original capping of the granitic series. Turning to a well-known region, namely to the United States and Canada, as shown in Professor H. D. Rogers' beautiful map, I have estimated the areas by cutting out and weighing the paper, and I find that the metamorphic, excluding the semi-metamorphic, and granite rocks exceed, in the proportion of 19 to 12.5, the whole of the newer Paleozoic formations. In many regions, the metamorphic and granite rocks would be found much more widely extended than they appear to be, if all the sedimentary beds were removed which rest unconformably on them, and which could not have formed part of the original mantle under which they were crystallized. Hence it is probable that in some parts of the world whole formations have been completely denuded, with not a wreck left behind. One remark is here worth a passing notice. During periods of elevation, the area of the land and of the adjoining shoal parts of the sea will be increased, and new stations will often be formed, all circumstances favorable, as previously explained, for the formation of new varieties and species. But during such periods there will generally be a blank in the geological record. On the other hand, during subsidence, the inhabited area and number of inhabitants will decrease, excepting on the shores of a continent, when first broken up into an archipelago; and consequently during subsidence, though there will be much extinction, few new varieties or species will be formed, and it is during these very periods of subsidence that the deposits which are richest in fossils have been accumulated. End of Chapter 10, Part A.